Okay, so I got this question here. Uh, this is number 14 on the sample final. You're given a quadratic function, and the first question is, what is the vertex of it? And hopefully you recognize this is the function's given in standard form. If it was vertex form, it would be a lot easier question. So if you have the equation in standard form, there's a couple ways to go about it. The first one is to use this little trick, and you'll recognize the top here is the quadratic formula. Well, the first part of the quadratic formula actually will give you the x-coordinate of the vertex. So if I look at the quadratic function, I can find the x-coordinate just by using negative b over 2a. So I plug in negative b is really positive 2, right? Over 2 times a, which is 1, is 2 times 1. That's 2 over 2, or 1. Okay, so the x-coordinate of my vertex is 1. The y-coordinate I just find by plugging in 1, the x-coordinate, into the function. So I'm just going to plug it in for the axis. So that's what? 1 squared minus 2 times 1 plus 1, and I get 0. So the vertex of this parabola, or this quadratic function, is going to be 1, 0. Okay. Now the other way to do this that we looked at, yeah, good. The other way to do this that we looked at on con was if you can find the two zeros, the x-coordinate of the vertex is always halfway between the zeros because of the symmetry of the parabola. So if I find the zeros of the quadratic function, I'm lucky here that I can factor. So I just get x minus 1 times x minus 1. That means x is equal to 1, x is equal to 1. This is where this technique is a little weird because the two zeros are the same, right? Which means there's only really one zero. Now, if you think about what that means, it's if a parabola has only one zero, that's meaning that the parabola hits the x-axis in only one place. Okay, which means that the zeros are actually the same as the vertex. So the cool thing here is it's kind of tough to realize. It throws a wrench in the system, but this actually gives you the x-intercept is also the vertex. So since the x-intercept is 1, 0, the vertex will also be 1, 0. Okay, because if a parabola touches the x-axis in only one place, then the 0 is the same as the vertex. Okay, so I hope that helps a little bit. I mean, you could also just do 1 plus 1 divided by 2, and then you get 1 still. Okay, you can actually find halfway between a point in itself, and that works as well. But it's easier just to realize, well, if I only have 1, 0, that's also the vertex. Okay, so I hope that helps a little bit.